Here we are dealing with three-phase AC generation. This is the theory questions only. So the first question, state two advantages of three-phase systems. Supply of power is constant. The load can be balanced in a three-phase system. A three-phase system is more economical. A three-phase system can be connected in star or delta. Both single-phase and three-phase loads can be powered from a three-phase system. It uses less copper in their conductors. A worldwide adoption for generation and distribution. State the voltage and frequency at which electricity is generated in South Africa. "22,000 volts is the generation and at 50 Hertz. Name three energy sources used to generate electricity in South Africa. Coal, wind, water. Solar, nuclear fuel energy. Describe or explain the transmission process with reference to voltages in the national grid of South Africa. After generation, the voltage is stepped up to a value between 220 kilovolts to 765 kilovolts. It is then transmitted over long distances by means of cables of aluminium and steel to distribution stations where it is stepped down before it is being stepped down further. Draw a fully labeled star system configuration. Remember to include all the labels. So a star system configuration has a neutral point. Therefore, it's a 4-wire system. Draw the voltage waveforms of a three-phase AC generator. So notice that they are 120 degrees apart, and in the diagram it would be required to label it as red, yellow and blue, and also showing the difference between the waves and have it at 120 degrees apart. It would be easier to start off with the red because that's your normal sine graph, and then after that follow it with the dashed line, this one here, which will be 120 apart. So then all you do from this point, draw another dot 120 away, and then draw another dot 120 away, and then from there go there, from there go there, and then from 120 away complete that one, and then just draw the piece. That would be the easiest way to draw that. Explain the terms efficiency, power factor and active power. So efficiency is the ratio of the output power to the input power. Power factor is the ratio of the true power to the apparent power. Active power is the power that is effectively used by the load. State three disadvantages of three-phase generation in comparison with single-phase AC generation. not available everywhere, high installation cost, not suitable for most residential applications. Three-phase appliances are more expensive. Now we have the distribution network. Name the processes at A, B, and C, and draw the waveform at A. So at A we will have generation, and that would be what is generated, just like above, three-phase. At B we have transmission, and at C we have, as I said, the distribution network. So this whole thing would be the national grid, okay, and then it is later stepped down for the distribution network. The voltage from the generation process must be stepped up to reduce the current in the transmission lines, and therefore reducing the copper losses. This is called the I²R losses in the transmission lines. Determine the type of connection used on the secondary windings of transformer 3 and motivate your answer. So star connection is at the end because both three-phase and single-phase equipment will work only on a star connection. This question is relating to the previous diagram. Draw the voltage phasor diagrams of a balanced three-phase system and show the direction of rotation. So the question could say, draw a three-phase system. So a three-phase system looks like this, 120 degrees apart, fully labeled as VBN, VRN, and VYN. In other words, the blue, the red, and the yellow. And don't forget to include the direction of rotation. There are alternatives to drawing this. It could also be drawn like this, as in the textbook. Also include the direction of rotation and 120 degrees apart. And so these are the ways that you could draw these diagrams. Both of them would be correct. You could also draw it like this, and that would be very much the same thing as the one on the left. So if you look at the diagram on the left, the diagram on the right, it's the same thing. But do include, when you draw it, VBN, VRN, and VYN for all three. Notice this one doesn't have the labels. Okay, so it would be good to include those three labels to get the full marks. Explain the term power factor correction with reference to three-phase generation. Draw the diagrams showing how power factor correction is carried out. So this is how power factor correction is carried out. We have L1, L2, L3. Make sure to include the labels L1, L2, L3. It is not necessary to draw this here. Now, all you have to do is place capacitors across the delta connection and place capacitors across the star connections. It's a very simple drawing. So 3 lines, L1, L2, L3, and a capacitor across each branch. Okay, same with the delta, and don't forget to label it as delta and star. Now Now the question said explain the term power factor correction with reference to three-phase AC generation. So power factor correction is the process of reducing the load's phase angle, thereby bringing the power factor closer to 1. Name 2 advantages of power factor correction to the supplier. An improved power factor reduces the current supplied to a system. Because of reduced current, thinner supply cables will be required. The cost of maintenance will be less. Now the question can also say, name 2 advantages of power factor correction to the user. So the user's equipment will last longer and the user will use less electricity. Those will be the benefits for the user. It will also be savings for the user in terms of cost because the electricity will be cheaper. Number 14. Differentiate between power transmission and power distribution. So power transmission is the large-scale movement of electricity at high voltage levels from a power station and a substation, whereas power distribution is the conversion of high voltage electricity at substations to lower voltages and distributed for use by domestic and industrial consumers. State 2 functions of a control center in a generation network. The control centers monitor how much electricity is needed throughout South Africa. They establish how much electricity must be generated. The power stations adjust the amount of electricity to be generated according to the instructions from the control stations. Draw a labeled representation of a delta connection. So this is a diagrammatic representation. We also get something called a schematic representation. Schematic uses only lines, and this one, diagrammatic, uses the actual coils. So instead of just having lines, diagrammatic uses the coils, like this one. Draw a labeled representation of a delta connection. So there are 2 types of drawings that one could draw. This is the one called a diagrammatic drawing. A diagrammatic drawing has coils like this one. The other one is called a schematic, where it's only straight lines. So in this case, it wasn't very specific as to which one should be drawn. So this one is the diagrammatic drawing, which has the coils. Do note that you need to label it as red, yellow, blue, and also show the direction of rotation. Draw the phasor diagram of a single phase system. So draw the phasor diagram of a single phase system. Okay, and because it is single phase, it has just one line with an angle, which is the phase angle. 3 marks for that drawing. State whether the phasor diagram represents a positive phase or negative phase sequence. Motivate your answer. What does phasor VRN represent? Motivate your answer. So looking at the diagram, answer this question. The phasor diagram represents positive phase sequence because the direction of rotation is anti-clockwise. Red, yellow, blue is the phase sequence. Phase voltage is the voltage between R and N. Explain the effect of stepping up the voltage in transmission lines. The current in the transmission lines are reduced, which reduces current losses. Define apparent power. Apparent power is the product of the applied voltage and the circuit current. Define the line voltage with reference to three-phase generation. Are the voltages between any two lines. These may also be referred to as line-to-line voltages. Draw and label a double subscript voltage notation for a delta connected three-phase generator. Right, and this is our schematic diagram of a delta connected three-phase generator. Notice you have to include all labels. Explain why the generated electricity is lower at the point of distribution than at the point of generation. Because of copper losses occurring in transmission lines, transformers step up voltages during transmission process, during the power transmission, in order to reduce current in the transmission lines. Question 24. The questions are at the bottom of the diagram. State the relationship between the values of the phase voltage and the line voltage in the above figure. Draw a fully labeled phasor diagram that represents what's going on in that figure. Right? So this is the phasor diagram that represents three-phase, and that system that you see on the left is three-phase. Remember to include all the labels and the direction of rotation. Right, the next one is power factor. So something that one needs to look out for here is the word IND on the top and CAP at the bottom of the meter. IND means inductor and CAP means capacitor. Does the reading show a leading or lagging power factor? Explain why. How can unity power factor be achieved? A lagging power factor because the load is inductive. Looking out for IND. This can be brought to unity power factor by using capacitors across the phase or by using phase advances. So when we at unity power factor, this means the power factor is equal to 1, and so that needle will be perfectly in the center. Here the person will be getting maximum power that they are paying for.